Thank you. So, what we're going to do is, if you're watching this, not walking away from it. I'm come back. We're going to start with exponents, kind of like we did on the puzzle yesterday. So, again, uber important. Most of all that I've got this stuff to work with from my note packet. That's what you're seeing here at the bottom of the screen. If not, when I show you at the end of this where you can get these and update them to have them for the quiz, you're going to want to get them updated. So I'm going to try to reference them a lot, and I'm also going to try and reference problems I see on here that could help us as well. So, okay, exponents. Simplify. No negative exponents or decimals. Okay, so the number one thing here to remember, actually there's two on this first problem. Number 1 and number 3. Okay? So big numbers don't play by little number rules. In other words, if things are positive, okay, we're going to leave them alone. They're doing fine. But if they're negative, that tells me right away there's going to be flipping. So I'm going to make this a fraction since it's not 1. And then I'm just going to go part by part and go, okay, 9 doesn't have a negative exponent. 9's happy. 9 gets to hang out and just keep doing its thing. X to the negative second is not happy where it's at. It's negative. So it needs a new home where it can feel better and be positive. And that's it. That's literally it. I have positive exponents. I do not have decimals. I'm done. Keep life simple, okay? Anytime there's a negative exponent, we just flip it the other direction, and it's set. And number 2 is going to be similar. I got a fraction. Y is happy. Y is positive. Leave Y alone. But x to the negative 2 does not like being in the denominator. It doesn't like being in the basement no more. So, bring it up here. It becomes positive. And you're like, okay, but now there's nothing left down here in the denominator. So what do I do? That's okay if it's the denominator. If you're like, I want to put something down there, I can put a 1. But again, no negative exponents, no decimals. I'm good. One step, just doing a little flipping. Now, this next part gets a little more interesting. Because as I look at it, I go, okay, so big numbers, my coefficients, 3 and negative 7, don't play by little number rules. In other words, we're still going to multiply those together. So 3 times negative 7 is negative 21. Now it's up to you if you decide at this point, hey, I don't like the negative exponents, I'm going to flip them right away. I could. Or, since we're multiplying here, when we're multiplying with exponents, we add them. So, I see a negative 7 here. What exponent's on that x when I don't see one? 1. So this, and I'm just going to show my work on this. I know some of you are looking at it and going, negative 6, but I want to actually show the steps here. So again, we're thinking through this. So when it's go time on the quiz tomorrow, you know where it came from, and you're not just like, I have no idea where this came from. I apologize. My 2 here does not look like an exponent, but it is. So same thing with my y's here. I'm going to take my y's, and I'm going to add my exponents. I'm going to show a little more work here than we normally would. So negative 21. Yeah, that 2 was supposed to be an exponent. It got big all of a sudden. That can mess with things. I agree. So x, don't lose your variables, to the negative 6. Notice I'm using the calculator for all of this. There's nothing wrong with doing that. So I add my exponents on my x's. I add my exponents on my y's. I notice there's negative exponents still. So do not circle that as your final answer, because we're not quite ready yet. So I get here and I go, okay, well, Hardy, that's negative. I need to flip it. No. We flip negative exponents. That's not a negative exponent. Leave the negative 21 alone. But if it's something that has a negative exponent on it, it is going to be happier if we flip it. So this, whoop, down to the bottom. Y to the negative 1, whoop, down to the bottom. And we're off and running. No negative exponents. Okay? Negative coefficients, the big numbers? Sure. Okay. But that's the type of things we're looking for. If I follow the rules down here on my help sheet, even if I didn't have any of the rest of the stuff below it, that should help me out. All right, let me move this up a little. So I look at the next piece, and I'm like, okay, I see parentheses. Okay, parentheses. Power to power. That's what this is when there's an exponent outside. We're going to multiply the exponents. So this 3 is going to that 3, that 4, and that negative 2. We will deal with the 3 to the third power here in a minute. We're just simplifying right now. 4 times 3. I'm just going to write it out so I know later what I'm doing. And negative 2 times 3. Because this might help me again on our puzzle from yesterday too, where I can get some extra points. Okay. 3 to the third power is not 9. Yep, if you're looking for your exponent button, again, it's right above the divide button here. So that's going to be 27. 4 times 3 is 12. Negative 2 times 3 is negative 6. Oh, I see a negative, which means there's going to be one more step to this because I got negative exponents and I can't have negative exponents. It says so right there. So I work and I'm like, positive, I'm good. Positive exponent, I'm good. Oh, why? Let me get you to a new spot where you're positive. Okay. So notice, I'm not flipping everything unless it's a negative exponent. It's cool. It's positive. It's happy. Leave it alone. Leave it alone. So I'm going to keep following the rules. I'm like, okay. So let's see, 3 divided by 12. Let me type this in. Don't get suckered in. That's not 12 divided by 3. We don't do decimals. Math and enter twice is 1 over 4, just like it says on my calculator here. And then we're going to subtract our exponents. So I look and I'm like, okay, there's my x's. 4 minus 1 is 3. Bigger exponents on the top. So I'll put my x to the third. What's 3 minus 3? 0. 0 means they're gone. Okay, if we get a 0 exponent, that variable's gone. So that one's done. I don't have any negative exponents or nothing. I just followed the rules and I was finished. So that's not a bad deal. And then this last one. Again, let the tools help you. 28 divided by 4 is 7. Okay, 7. Now here I have a choice. Could I do 7 minus negative 4? I could. That would work. Or I can say, hey, I don't like this negative exponent. I want to flip it up here and make it positive. and just deal with it that way. Because now by flipping it up top, I'm multiplying these together. So we're going to add the exponents. No negative exponents. I'm done. Okay, so we're just going to keep using these same rules up here at the top. So it's critical I have those there to help me get some guidance as I'm working through these. Okay, let me move down a little. If we got to come back to some exponent stuff in a bit, we will. So I'm like, all right, let's see here. Graphing with growth and decay. All right, let's do this. Let's move this up a little bit. We'll have to get some help. Again, I've got all my button things down here to help me out with what buttons do I hit to help me when I'm doing this. So first things first, I hit the y equals button to be able to put my equation in. If there was something typed in there already, okay, we're going to hit the clear button to get it out of there. So there's clear. Okay, that's out of the way now. And I want to type this. Let's get back down here. So 3, that's not 3 times x, that's 3 to the x power. So again, here's my exponent button, just like we say here, right above the divide. Here's my x. But that -4 is not up in the exponent. So to get that out of there, we're going to right arrow to get it back down. -4. And again, any of this stuff I'm doing with the calculator presses, if you need to, you can put that stuff on here. There's nothing wrong with that. So once I get it here, I hit graph. There it goes, whoop, up to the right. So just as a reminder, if your graph is going up to the right, that's growth. If your graph is going down as it's going to the right, that would be decay. We're just trying to keep these things straight. Okay, the next one is supposed to be the easiest question of all time. Should I get my graph first? I probably should. Hardy, should I just sketch it? No, we want to get the actual points. So to get the chart, we're going to do second and graph. And we get that part. And we're just going to let the chart help us get some values here. So we got 0, -3. 1, -1. And 2, 5, and then the rest of them don't fit. They get kind of big. So I'm going to use those as my guide to make my graph, but there's one other thing I'm going to mention. We've talked a lot about how this plus or minus number at the end is telling me where my do not cross line is. So this do not cross line is occurring where y equals -4. And if there's no number there, we just use 0. But why is that important to even bother drawing? Because now when I go to sketch my graph, I know, ooh, don't go through there. We're just going to kind of line up and keep going. Kind of just curves and keeps going. So let the chart help with getting your graph ready. Okay, domain, the easy one. Like, you don't even have to see the problem. Your domain is always infinite. Now, why is that? Because it's going forever to the left. Remember, domain is my x values. Yeah, from left to right. Forever left. And this, even though it looks like it's going up, it's also stretching out as it's going as well. So domain is the easy peasy one. The range, my y values from bottom to top, Okay, this is another reason why I wanted to put my do not cross line in. Because I see it goes up forever, but it doesn't go down forever. It only goes down until I make it to the do not cross line. So there's always a connection between this number and where my range starts. Again, that's a connection I want to make, and I want to make sure I have it on my notes. And I do, because if I look at my notes, I'm like, see, +2. Oh, I drew it in at 2. Oh, it's 2. 2 and 2. It's 0. Line's at 0. It starts at 0. If you practice that and you see it, it makes it easier. Okay, let's see if I can get a little more help here from what I've got. Do I have my intercepts on here? It doesn't look like I do. So this one we got to think about. We might even add this. Let's do this. Y-intercept occurs when x equals 0. Now, I do not see that on my notes, so I'm going to help myself out here. I'm going to add a little something. Y-intercept always occurs when x equals 0. So what's the easiest way to deal with that? Well, duh. I'm going to pull it up on my chart. My second graph, because if I go to the chart where 0 is, x equals 0, there's my y-intercept. 0, -3. I can see it there on my graph too. And so I'm making these connections. F of -1, whatever number's in the parentheses, that's the x value. Okay, if I go to where x is -1, boop. I just put the value in. Literally, for both of these, every time, the calculator will tell you the answers to both. You don't have to do anything. You just got to find it. So x is 0 on the y-intercept, and it's the number in parentheses there, and I can pull it off my chart, which I know how to do because it's right here on my notes. Okay? Use the tools. Use those tools. They can help. They really can. Okay. Again, cool thing is later when I've got some of this stuff posted, if you need to go back and update something or change something with your notes, you can. What's that? Yep. Yep, I got an answer key up here, and I got it online too. Okay, growth and decay word problem. Oops, probably help if I had the problems on the screen. Here we go. Okay, we deposit $1,200. Deposit means we're adding, so that's going to be plus. These are the ones where we said, okay, I got to label my parts. So for this one, my starting amount, my P, is 1,200. That should be R. How does that keep turning into I? I'm just going to rewrite it up here. I do know that on the quiz it's R. I don't know why that got changed to I. That's kind of silly. So my P is 1,200. My rate, we always are taking our rate, in this case the 6, and you divide it by 100. Just like we have it on here. 0.06. And my time is 17, whatever the number of years is. Literally, plug and go. P1 plus my rate to the time power. So I type that in exactly as I see it. Again, my exponent button right above the divide. And since we're talking about money, we're going to go to the nearest cent. I don't want to go to all those decimal places because nobody goes up and says, yes, your bill today will be $3,231 and 327 and 343 hundred-thousand cents. That nobody does that. That was even ridiculous that I tried. So And you've got an example, again, a couple of examples down here as well to help. One more time over here. Again, all we're doing is taking the numbers. This time it decreased. It went down in value. Cars do. I take my 9, I divide it by 100, because I need the decimal, in 5 years. So I've got the equation. Even if you just get the equation, you're getting points. So again, just show me a little something. Oh, what did I do? Oh dear, that's not good. Let's try that again. Okay, now that looks better. Okay. So again, we're talking about money. So to the nearest cent I go, as we're working those. But again, I've got the info, I've got the examples here. I got my notes done. Now we go into rewind mode. Uh-oh. 6162, we're back to Unit 6. You can use your Unit 6 notes if you have them. Now, if you don't, you're going to want to pay good attention here because we got to know what we're doing. Okay, solve the system by graphing. Make sure to rearrange for y. Okay, if it's not already in y equals like this one is, that one's ready to go. This one, I got one step to get y by itself. What's my one step to get y alone? How do I undo the minus 2x? How do we undo this? Yeah. Because that's math. That's true. And we always want to have the x part first. So now, when I go to graph, y-axis, x-axis. One way I can graph this is by saying, okay, there's my y-intercept at 5. Y, not x. Now, this is the part that gets a little interesting. You're like, okay, so I'm going to go up 2. Hardy, I can't even go up 2. So let's talk about this for a minute. So normally, this would be up 2 and right 1, but I run out of room. Remember, I can change both of them and end up on the same line. So I can go down 2 and left 1. Down 2 and left 1. And I'm going to go a little crazier with the dots this time, even though I wish I was doing red. I'm going to. Just a minute here. Oh. Because I'm looking for where they cross exactly. Now, if graphing lines is not my strength, you can do exactly what we were doing a minute ago. Type it in on your here and just do second graph, just like we did on the example problems, and check it out. 0, 5, negative 1, 3, negative 2, negative 2, 1, 3. You can get all the dots and do it this way too, and let the calculator do it for you. So you have choices, okay? You have options. I do it for the other one. Okay, 3 is my y-intercept. What number's in front of x when I don't see one? 1. So again, I can go up and right. Up 1, right 1. But I also go down and left, down and left. There we go. There will be a point where they cross right here. And so I need to know the coordinate point of that. So if I follow it back to the x-axis, that's at -2. And if I follow it back over to the y-axis, that's at +1. And I can do that. And play that as well. So our biggest thing we're finding with this is, again, practice does make better. These were on the puzzle sheet yesterday too. So if nothing else, this is a good way for you to get some practice in on that as well. So systems with substitution. We're almost there. This is the end. If, oops, that wasn't a color. Let's try that again. There we go. If they're both y equals, and they are this time, we're just going to set them equal to each other because they're both y equals. And we're going to solve this. And so my first job is to get all the x's together. It doesn't matter which side. But since they're on opposite sides, we got to do an opposite to move them. So we'll wipe them out on one side. And again, just take your time. Make sure you're doing opposites. These will come out as whole numbers. If you get decimals down here, something went goofy. All the x's are together. Now we want to get them alone. So goodbye, -13. Oh, I'm going to squeeze this in here yet. And divide by 5. So I've got my x value. So this is my first part. Set them equal. Find my x value. Let's go this way. And then to finish it, I always just plug it into the top one. You can plug it into either. So y equals 3 times x, but I know what x is now. It's 6. Everything else stays the same. And I can even type that into my calculator. 3 times 6 minus 30. Whoops. I got to type it in right, though. There we go. Again, every one of these is on not only a couple of the homeworks that we have within our practice packet, but also in the puzzle. I keep saying that over and over. The puzzle, the puzzle. Well, what if they're not both y equals? One of them will be. And we're going to be substituting it in for that y. So I start copying the second equation until I get to the y. Then I replace the y with what's in the box. That's why we put the circle here. Everything else stays the same. But you notice, now there's only one variable. So we're going to do a little distributing over here. 4 times -1 is -4. Again, use the calculator if need be. 4 times 3 is 12. Now here's where we've got a difference between this and what we were doing over on number 1. On number 1, my x's were on opposite sides of the equal, so I had to do an opposite to move them. They're not on the opposite side of the equal anymore. They're together. So when they're together, we go ahead and we just combine them. So like 3 plus, whoops, -4. No, 3 plus -4. There we go. But once I get that step done, then I'm just doing opposites to get that x term by itself. And the only thing I got to be careful of here is this isn't add 1 to both sides, we're multiplying, so we got to divide. So I end up with -3 for my x. And here, now this gets a little interesting too. That negative is there. And then this is -3. That's a little tricky, but we're gonna get it. As long as you get the signs right, again, your calculator can be a great tool as long as you just copy stuff correctly as you go. So hearty suggestions as we wrap review stuff up. If all you do is do this together, write it verbatim with me, and do nothing else before tomorrow, nothing is going to change. It's going to be the same struggle as it always is. If you take this opportunity to use this and then work through the preview puzzle that we were doing yesterday, because now you have another tool to help you with what the problems do, that will give you more to think about. It will help you if you update your notes to make sure that you've got all the different options that you need as you're going along in Classroom. That will help. If you do the regular practice from the unit that we just got done with here, okay, there were lots of pages, lots of practice. That'll do well. Hang on a minute here. If you are still in need, okay, let me get past that one. Here's the calculator button presses. Do you need them on your note sheet? Maybe. If you do, put them on there. Do you still need the notes? There's all the notes. Every last bit of them. They're all here. I got copies around the room. You've got tools if you choose to use them. That is going to be your